Hi. Today I'm going to talk to you a bit about what I do. But to explain what I do, I thought I'd take a bit of time to explain what engineering is, and then what a structural engineer is, as opposed to every other type of engineer, and then my experiences so far. So firstly, what is a structural engineer? Well, to know what a structural engineer is, you're probably wondering, what is a structure? Well, a structure is anything that, I guess in the most basic form, resists forces. So the most common force that needs to resist is gravity. So if you're sat on a chair at the moment, the chair's stopping you falling to the floor, so that's a structure. You might be sat in school on the first floor, so the building is actually stopping you falling to the floor, so that's also a structure. Then another common force is wind. So if you're in a school or when you're at home and it's really windy and raining outside, the wind will try and push your house sideways, but your house stops that happening. It doesn't just blow away, so that makes your house a structure as well. But buildings and chairs aren't the only types of structure. Everything around you pretty much is resisting some sort of force, even if it's just gravity. So other examples are wind turbines, or cars, or planes, or bridges, and even tents, because structures don't have to be permanent. So what is structural engineering? Well, structural engineers work with lots of different other professionals. If we just concentrate on buildings for the moment, so if we think of a building a bit like a body, the architect is the person who designs how it looks, thinks about how it makes you feel, whether it's tall, whether it's short, whether it's big, whether it's small, what colour the clothes are, the detail of which shoes they're wearing. So they're kind of interested in the layout and how things look. The structural engineer will be designing the skeleton, so making sure that everything doesn't just flop to the floor. So like I said, we resist the forces. The mechanical engineer will be looking after all the different systems that are pumping things around your body. So the heart for the blood, your digestive organs to make sure you can digest food. And then the electrical engineer will be responsible for the nervous system, so to make sure signals can get from your brain to everywhere else in the body. And then finally, the quantity surveyor will add all this up and figure out how much it costs, or in the case of a body, how much it weighs. So if we put that in the context of cities or the world around us, then structural engineers help design the infrastructure around you. So whether that's buildings or train stations or airports, or even just the railing on the footpath that stops you falling in the river. So how is that different to an architect? Well, as I was saying about the body analogy, an architect wants to consider how the building feels, what it looks like, how it's laid out, and how it makes you feel. Whereas a structural engineer wants to make sure it stands up. So we want to make sure it resists all the forces. So some of the ones I said before, like gravity and wind, but also other ones, like if it gets really hot and the building wants to expand, and that puts forces into different things. How do we resist those? And if you're in an earthquake area, there's also seismic forces if there's an earthquake. So I've mentioned a few people we work with. So electrical engineers and mechanical engineers were mentioned before, but we also work with all different types of engineers. So geotechnical engineers look at what the ground is doing, civil engineers, water, transport, there's all sorts. So it's a really varied profession, and you get to work with lots of different people. So it's not just technical. So now I'm just going to explain a bit about how I got into engineering, or how I got where I am today. So when I was at university, I was there for 4 years studying general engineering to start with, and then civil and structural. But one thing I worked on was a research project. So we were looking at a housing design for use in El Salvador, which is a country where there's lots of earthquakes, and there's quite a lot of people who don't have much money. So we wanted to come up with a housing design that was cheap. It uses local materials, so it's sustainable, but also it could resist earthquakes. So we came up with a structure that uses layers of bamboo, because bamboo is really flexible, so it can absorb a lot of energy in an earthquake. and then it has layers of mortar on it, so a bit like concrete, has cement in it, but doesn't have stones. So that is all held in place by a wire mesh. So that was our idea, but then we wanted to test it. So we built a test rig, and then we basically shook the panels to see what happened. And as you can see on the right, the cement, so the mortar fell off, but because it was attached to the panel via the wire mesh, it didn't actually fall off the panel. So that would be good in an earthquake, because it would be safe for the occupants to be able to get out of the building, because the concrete wouldn't fall on them. So then I started working for BuroHappold. So what does BuroHappold do? Well, we've designed or done the engineering for a lot of different buildings that you've probably seen or heard of, but you've probably never heard of us. So we've done lots of things like the O2 Arena, the Olympic Stadium, the, well, not so new now, the Arsenal Stadium, the new Tottenham Stadium. We work on, so that's just one team within our company that's like 20 people. They have all sorts of other projects. So the one on the bottom left is the British Museum, if you've ever been in there. And that's a really interesting curved structure, the roof. And then we work in different countries as well. So the one on the right is in China. And that's unusual because the crisscrossing external structure you can see there actually is critical to holding the building up. So I also, another project I worked on was in Tanzania, so a bit different to structures. This one was more about, I guess, basic things we take for granted in the UK. So clean running water and clean toilets. I'm sure you all have them in schools and at home, but in a lot of places in the world, I think something like nearly, I don't know, over 1 billion people or even more than that don't have access to clean toilets. And as a result, they often have, they can end up with raw sewage running down the street, like you can see on the left, which is obviously not very hygienic and can make people ill. So I worked on a project in what's called an informal settlement. So it's not officially registered by the government. The houses, people who live there might not have much money. And so because it's not formally registered with the government, they don't have many services that we have. So we worked with the local community and the local government to install a network of toilets. And we used a version of sewage pipes that is cheaper and easier to build and easier to maintain than what we have in England. Because it's really important to think about the context of what your problem is, and not just apply one blanket solution regardless of the surroundings. So you can see on the right, I was out in Tanzania for 3 months helping to run the project, looking at how much it was going to cost, getting the local community involved and helping to build it. So a great thing about engineering is you actually get to see your design come to life. And again, there's lots of different facets to it, working with lots of different people. So I mentioned the Tottenham Stadium earlier. I spent 3 years working on that. So that's I guess one of the biggest structures you can think of. Requires lots of people. So just structural engineers alone, there's about 30 different people working on the project. And my bit was looking at the design of the east and west stands. So looking at when people all go on the seats and all the different bar equipment that's under the seats. You know, how are we going to get that load down to the ground? So what size, the diagonal members we call rakers. So what size rakers are we going to need to make sure that the stand is safe, but also that it doesn't bounce too much when everyone jumps up if the goal's scored. And then also looking at the different members behind, so to resist the wind, like I said, to resist the bars or the restaurants that might be sat in the stadium. So on the left, you can see one of the models we used to help analyse what forces were acting. And then on the right, I was lucky enough to be on site for about 6 months. And you can see your design coming to life. So again, really exciting to be able to see what you've designed actually be built, and then so many people enjoying it. Another project on a much smaller scale to show the sort of variety we work on was a puppet. So the mines down in Cornwall, I think it was something like 150 years since they became a UNESCO World Heritage Site. So they wanted to do something to celebrate. So they commissioned a 12-meter high puppet, and it's sort of to evoke the miners. So it's all metal, and then all the men in orange kind of pulling it, so making its arms move and legs move. But because that's such a big structure and there's lots of visitors come to watch, need to make sure it's safe, it doesn't fall over, that parts don't fall off. So again, getting involved in a much smaller, simpler level, but just as important to make sure the structure is safe and stands up. Another project I worked on abroad was in Rwanda, so with a charity called Bridges to Prosperity. So in England, you probably take for granted there's a river or a road, you can just get across it, you go on the bridge. But in many parts of the world, there isn't just a bridge, because it's not that easy thing to build or just make happen, and they don't necessarily have the money to build them or the skills. So we went to Rwanda and we helped to build this footbridge, which meant that people could cross the river safely to get to school, to get to hospital, or to get to the market to sell their produce. So again, another example of teamwork, working with the locals, working with different engineers in quite a short time frame, and be able to have a meaningful impact on people's lives, which is really good. So that's a bit about structural engineering and what I've done and do. But how do you get into structural engineering or engineering in general? Well, there's lots of different ways. So I did GCSEs, and then I did A levels, and then I went to university. So at university, you typically study a bit more the theoretical side, so maths and physics based and problem solving, and do some different group projects, and then you start work. But you can also, you don't have to go to university. You don't have to do A levels. You can do a diploma. You can do an apprenticeship and work on the job, and sometimes if you do well in your apprenticeship, your company might sponsor you through university. So there's lots of different routes into it. So yeah, I think basically if you like maths and science and solving problems, I think engineering is a really great thing to do to have an impact on the world around you. And obviously, like we've seen with Greta and all the climate strikes recently, we need to come up with solutions to problems in the world. And engineering allows you to actually do something practical and try and make a difference. So yeah, that's kind of what I've done so far, but kind of talked about that. So yeah, that's all. Does anyone have any questions?
Okay, so Mount Kelly and St Catherine's, if St Catherine's can hear me, if you have any questions, could you type them into the chat facility, please? And Mount Kelly, could you make sure that both of you, can you make sure that the drop-down box says to everyone so we can all read them as well? Usual couple of minutes wait. There you go, there's your first one, Ellie.
Okay, so of all the projects you showed us, which ones have you worked on? So I didn't work on the original design of the Millennium Dome or the conversion to the O2 Arena, but I did work on, they've put more shops and cinemas and trampoline parks inside, so worked on the buildings for that. And then I didn't work on the British Museum or the one in China, but all the other projects are ones I've worked on. So yeah. Another question. How hard is it to become involved in this form of engineering? Well, actually, in the UK, not many people know what engineering is. So it's a really exciting profession, and there's loads of different career options within it. But because not that many people understand what we do, it's not as competitive maybe as, I think it's becoming more competitive, more people understand. But if you're interested in maths and physics, and then you study engineering, then you're quite likely to get a job. There's probably as many jobs as people want jobs. So yeah, it's not, I mean, you have to be able to solve problems and work with people. But if you're interested in that sort of thing and you work hard, then yeah, I don't think it's too difficult. What qualifications do you need for engineering? So I think generally the main things, you need to do maths and physics in A levels, and then you can either go and do an apprenticeship. Yeah, you might actually have to do an apprenticeship straight after GCSEs. I think some people at work might have done that. But yeah, and then either do an apprenticeship in engineering or go to university and study engineering. But there's lots of different types of engineering you can study. And then once you start work, you're often working towards becoming what's called a chartered engineer. So that's kind of like being qualified as a doctor or something like that. So it kind of shows you're at a certain level, you're safe to design buildings. And that normally takes about 3 to 6 years, depending on your experience. Do you prefer buildings or large frame structures such as bridges? Well, I think bridges are quite cool because they're quite driven by engineering, because they're long spans because they've got to get over a river. The architect's not as involved, so the structural engineer will get more of a say in what it looks like and how it works. Basically all my experience has been in buildings, and I guess bridges can link communities, but I guess buildings on average, people interact with them a lot more. So, you'll be in your school every day, I'll be in my office every day, I go home to my house every day. And yeah, there's a lot more people involved in the design of buildings. So yeah, it depends what you prefer, but I think my experience so far has been a lot more building focused.
Yeah.
Cool.
Well, thanks, Mark Kelly. We haven't had any questions from St Catherine's, and we had no communication. I'm not sure whether they're actually there, so I think we might as well close the meeting if that's okay with you, Ellie.
Yeah, that's
Yep.
fine. Okay.
So thank you very much.
Yeah.
Quite a number of schools didn't bother to log in this morning. I have no idea why, but thank you very much, and thanks, Mark Kelly. And I'm going to close the meeting now. So I'll send you an email shortly, Ellie. Okay.
Okay. Thanks.
Thank you.
Bye.
Thank you all. Bye bye.